Chapter 6. Pharmacology. Everybody Must Get Stoned. In 2012. In the waters off the southeastern coast of Africa, Emmy Award-winning wildlife photographer John Downer set up a series of hidden cameras in an attempt to nab footage of bottlenose dolphins in their natural habitat. He deployed underwater cameras disguised as squid, others hidden inside fish costumes, even some dressed up like sea turtles. All of this was done in the hope of capturing more relaxed behavior from the animals than would be possible with traditional filming techniques. And it worked. The dolphins in Downer's footage did appear more relaxed than normal. Way more relaxed. That's because the dolphins were high as kites on puffer fish, caught on film for the very first time. A dolphin grabbed a puffer fish off the ocean floor, chewed on it for a little while, then passed it along to another dolphin in the pot. For a moment, it looked like the animals were playing a game of underwater catch, but it didn't take long for the terrorized puffer fish to release its primary defense mechanism, a yellowish cloud of deadly nerve toxin, which, in light of what happened next, seemed to be exactly the dolphin's plan, while fatal in large doses. In small amounts, puffer nerve toxin is intoxicating, inducing a potent shift of consciousness that produces a trance-like state in dolphins. After ingesting a hit, the animals in Downer's footage huddled in a tight pod, smiles on their faces, tails pointed toward the seafloor, snouts tickling the water's surface. They were hanging around with their noses one at the surface as if they were fascinated by their own reflection, Downer told the International Business Times. It reminded us of that craze a few years ago when people started licking toads to get a buzz. When the footage was released, it caused a bit of an uproar. Headlines like "Do Stone Dolphins to Give Puff Pass a Whole New Meaning" became popular, and YouTube viewings rose into the millions. But really, stoned dolphins should have surprised no one. Psychopharmacologists have spent the past few decades cataloging the consciousness-altering techniques of animals in the wild, and they have found plenty to document. Dogs lick toads for the buzz. Horses go crazy for locoweed. Goats gobble magic mushrooms. Birds chew marijuana seeds. Cats enjoy catnip. Wallabies ravage poppy fields. Reindeer indulge fly agaric mushrooms. Baboons prefer iboga. Sheep delight in hallucinogenic lichen. And elephants get drunk on fermented fruit. So commonplace is this behavior in animals that researchers have come to believe that, as UCLA psychopharmacologist Ronald K. Siegel pointed out in his book Intoxication, drug seeking and drug taking are biologically normal behaviors. In a sense, pursuit of intoxicating drugs is the rule rather than the exception. This has led Siegel to a controversial conclusion: the pursuit of intoxication with drugs is a primary motivational force in organisms. So potent is the urge to get out of our heads that it functions as a fourth drive. A behavior-shaping force as powerful as our first three drives: the desire for food, water, and sex. The bigger question is why intoxication, in animals as in humans, is not always the best strategy for survival. The carcasses of drunken birds 5 litter the highways, acknowledges Siegel. Cats pay for their addiction to pleasure plants with brain damage. Cows poisoned with rangeweed may eventually die. Disoriented monkeys ignore their young and wander from the safety of the troop. Human beings are no different. But if mind-altering substances are so dangerous, why would any species take the risk? If the goal of evolution is survival and propagation, behaviors that threaten this mandate tend to get edited out over time. But the fact that drug use is as common in the jungles of the Amazon as it is on the streets of Los Angeles suggests that it serves a useful evolutionary purpose. Researchers have been pondering this for a while now, and have concluded that intoxication does play a powerful evolutionary role to patterning. In nature, animals often get stuck in ruts, repeating the same actions over and over with diminishing returns. But interrupting this behavior is not easy. The principle of conservation tends to rigidly preserve established schemes and patterns, writes Italian ethnobotanist Giorgio Sommarini in his book Animals and Psychedelics. But modification requires a depatterning instrument, capable of opposing, at least at certain determined moments, the principle of conservation. It is my impression that drug-seeking and drug-taking behavior, on the part of both humans and animals, enjoys an intimate connection with depatterning. In more contemporary terms, both Siegel and Sommarini have argued that animals consume psychoactive plants because they promote lateral thinking, or problem-solving through indirect and creative approaches. Lateral thinking involves big intuitive leaps between ideas. These are outside-the-box insights far more than iterative improvements, and much more difficult to achieve during normal waking consciousness, with our self forever standing guard over our ideas. Crazy schemes and harebrained notions tend to get filtered out long before they can become useful. But intoxication lessens those constraints, and the evolutionary advantages of intoxication benefit all involved. In his book The Botany of Desire, Michael Pollan argues that coevolution, when two different species come together, often without knowing it, to advance each other's self-interest, also extends to humans and intoxicating plants, in return for helping mind-altering plants propagate and outcompete other species. These same plants have evolved even greater psychoactive properties for us to enjoy. Plants, Pollan explained in a recent essay, evolved to gratify our desires. We give them more habitat, and we carry their genes around the world. This is what I mean by the botany of desire. Our desire for intoxication, for changes in consciousness. A powerful force in natural history. 7. But there are a couple of limitations that have long kept this coevolutionary force in check. The first is location. Elephants are drunkards and not crackheads because coca grows in the Andes and not in Africa. Baboons never sample the mushrooms of the Arctic tundra and have to rely on iboga for their kicks instead. Dolphins flirt with lethal poisoning because they can't score any hooch. Humans to have remained largely bound by geography until the arrival of global trade and travel. The substances we could use were the ones that grew around us. The second limitation is culture. Anthropologists have discovered that as soon as a local intoxicant becomes enshrined in tradition, people grow suspicious of imports. Most cultures, explains Pollan, curiously, promote one plant aid for this purpose, or two, and condemn others. They fetishize one and they have taboos on others. This explains why, when Franciscan priests arrived in Mexico 9 and found the peyote cactus at the center of the local religion, they outlawed the plant and enforced their own preference for sacramental wine. Conversely, in 1920s Prohibition America, 10 growing apples, which could be fermented into hard cider, was against the law, but tinctures of opium and marijuana were readily available at the local pharmacy. These are the constraints of the botany of desire. Geography and culture, together, they have prevented us from fully expressing that fourth evolutionary drive, the irrepressible desire to seek non-ordinary states of consciousness. And since different chemical compounds unlock different states, these restrictions have limited our access to the repatterning benefits of different types of cognition. But pharmacology, and specifically the branch of pharmacology that deals with psychoactive compounds, changes the rules of the game. It gives us access to more substances than ever before. And this provides us with more diverse data to consider. And perhaps no one played a bigger role in rewriting those rules than renegade chemist Alexander Shulgin, the Johnny Appleseed of psychedelics. Alexander Shulgin was called many names over the course of his career. Wired dubbed him Professor X. 11, while the New York Times preferred Dr. Ecstasy. 12, as he was a tall man with a shock of white hair and a thick beard. Gandalf was not uncommon. 13, more formally, Shulgin has been described as a genius biochemist, a pioneering psychopharmacologist, and, according to the Drug Enforcement Administration, a dangerous criminal. And his friends knew him as Sasha. Sasha Shulgin was born in Berkeley, 14, California, in 1925. Something of a boy wonder. He got a full scholarship to Harvard to study chemistry at age 15, but dropped out after a few semesters to join the Navy after the end of World War II. He picked that interest back up, getting a PhD from the University of California, Berkeley, before taking a job as a senior researcher with Dow Chemical Company. It was there he made two discoveries that would shape the course of his life. The first was Zectrin, a biodegradable pesticide that turned into a highly profitable product for the company. The second was mescaline, a drug he tried for the first time while working for Dow. He was amazed that a tiny bit of white powder could produce such a big reaction. I learned there were worlds inside of me. 15, he said, and understanding those worlds became the central quest of his life. Sasha's interest, explains Johns Hopkins 16 psychopharmacologist Roland Griffiths, was exploring the nature and limits of the human condition through tweaking some of these molecules to produce different and interesting kinds of effects. That's really, at its heart, what clinical pharmacology is about. We're studying the nature of the human organism. After his blockbuster pesticide, Dow gave Shulgin the freedom to pursue his own interests. Not surprisingly, he chose to focus on psychedelics, starting with mescaline, modifying the drug one atom at a time, and testing the results on himself. As unorthodox as this may sound today, self-testing was the standard in psychopharmacology for most of the past century, and Shulgin took up this practice with vigor. He tried out every variation of mescaline he could create, then moved on to other compounds. This all took place during the turbulence of the 1960s, and Dow grew increasingly uncomfortable with holding patents on drugs the government was fighting to stamp out. When Shulgin's recipe for the potent amphetamine Dom was duplicated by underground chemists and sold to unsuspecting hippies, triggering a nationwide spike in emergency room visits, the company hit the breaking point. They decided it was time to part ways. So Shulgin went into private practice, becoming an extremely independent contractor. After converting an old garden shed into his lab, he picked back up where he had left off, formulating and testing new psychedelics. Between 1966, when he first set up his backyard workshop, and his death in 2014, Shulgin became one of the more prolific psychonauts in history. He developed and tested, first on himself, next on his wife, and then on the small circle of friends who served as his research group, more than 200 compounds. To put this accomplishment into perspective, in the 1950s there were about 20 known psychedelics, including LSD, psilocybin, and DMT. By the 1980s, Shulgin had expanded that list to more than 200. Out of all these experiments, Shulgin is best known for resynthesizing MDMA, a compound first developed by German pharmaceutical company Merck in 1912, noticing it powerfully boosted empathy, and telling a few psychiatrist friends that it might have therapeutic potential. Those friends tried it out for themselves and were impressed with the results. They started using it with patients, and those patients told their friends, and pretty soon word hit the street of a love bomb in pill form, and the ecstasy craze was born. Shulgin also cooked up stimulants, depressants, aphrodisiacs, and a bunch of stranger chemicals, drugs that slowed time, drugs that sped it up, drugs that produced powerful emotional reactions, others that deadened feeling completely. In addition, he developed the Shulgin rating scale, 17, a 6-level system going from - for no result to plus for a rare and precious transcendental state, and took copious notes. At 22 milligrams, 18, he writes about the psychedelic to degrees Celsius T2. A slow onset. It took an hour for a +1. And almost another hour to get a +++. Very vivid fantasy images. Some gray-yellow patterns a la psilocybin. Acute diarrhea at about the 4th hour, but no other obvious physical problems. Erotic lovely. Good material for unknown number of possible uses. Better try 20 milligrams next time. Remarkably, Shulgin did all of this in plain sight of the law. In order to test these substances legally, he obtained a Schedule I license from the D. Along the way, he developed a friendship with Bob Sager, head of the D's Western Laboratories, and began holding seminars for agents, supplying them with samples, and occasionally testifying in court. In 1988, he authored what became the field's definitive reference book, Controlled Substances, Chemical and Legal Guide to Federal Drug Laws, which won him several law enforcement awards. But it was a pair of different books that came to define Shulgin's legacy. The first was PIHKAL, short for phenethylamines I have known and loved, a reference to the class of psychedelics containing mescaline and to degrees Celsius B. Co-written with his wife and published in 1991. PIHKAL was divided into two parts. Part 1 contained a fictionalized autobiography of the couple. Part 2 was a detailed description of 179 psychedelics and included step-by-step instructions for synthesis, bioassays, dosages, duration, legal status, and commentary, that is, everything a would-be psychonaut needed for takeoff. The second book, TIHKAL, came out in 1998, with the acronym standing for Tryptamines I Have Known and Loved, and referring to drugs like LSD, DMT, and ibogaine. In this volume, the Shulgins included recipes for 55 more substances along with even more commentary. Use them with care, they wrote, and use them with respect as to the transformations they can achieve, and you have an extraordinary research tool. Go banging about with a psychedelic drug for a Saturday night turn on, and you can get to a really bad place. Not that their cautions prevented the inevitable banging about, or avoided the predictable consequences. 2 years after they published PIHKAL, Richard Myers, a spokesperson for the D's 19 San Francisco office, told reporters, "It is our opinion that those books are pretty much cookbooks on how to make illegal drugs. Agents tell me that in clandestine labs they have raided. They have found copies of them. So they raided Shulgin's lab, fined him $25,000 for violating the terms of their agreement, and yanked his Schedule I license, while a variety of government agencies continued to surveil Shulgin for the rest of his life. He was never charged with a crime, nor, as Rick Doblin, founder of the psychedelic research nonprofit MAPS, explains, did he ever regret his decision. Sasha, Doblin says, was fiercely in favor of personal liberty. He felt these kinds of consciousness-expanding experiences were crucial to the world's spiritual and emotional development. His decision to share his research came from a real fear that he would die with this enormous body of knowledge trapped inside him. Even before PIHKAL, Sasha had that open-source impulse. He gave away information to anyone who asked. It didn't matter if they were D agents or underground psychedelic chemists, but after publication, When the crackdown came, it was like locking the barn door after the horses had already gone. The research was out there and Sasha knew. Even if the contemporary climate was hostile to these substances, sometime in the future things would change and his work would be very useful. By publishing his psychedelic cookbooks, Shulgin bypassed the geographical and cultural limits of the botany of desire. In open sourcing these recipes, he distributed hundreds of tools for investigating consciousness and changed countless lives. Everybody knows who the Shulgins 20 are, wrote T. Ferry, a close friend of the couple, in her widely circulated essay, No Retirement Plan for Wizards. It's pretty much impossible to overstate their collective contribution to psychedelic culture and indeed to the very fabric of human society at large. They not only brought us most of our favorite alphabetamines, they tested them on themselves and published their extensive notes so the rest of us could benefit from their groundbreaking discoveries. Sasha is the greatest psychopharmacologist who ever lived, and is a pioneer in the field of empathogen-assisted therapy. Their love story has inspired millions of people, and that's just for starters. This is your brain on drugs. While Shulgin definitely got things started, his impact was primarily felt on the edges of society, in law enforcement and the counterculture. But it's next-generation psychedelic researchers like Robin Carhart-Harris who have brought that impact directly into the mainstream. Carhart-Harris didn't start out 21 interested in mind-altering substances. In the beginning, when completing a master's in psychoanalysis at Brunel University in England, it was the unconscious that caught his attention. Here was a part of our mind that seemed to govern so much of our behavior. He explains, yet it was incredibly difficult to study. I was in a seminar where the class leader rattled off all the different methods we use to access it. Free association, dream analysis, hypnosis, bungled actions, slips of the tongue. None were very good, except for dreaming. They're all indirect approaches, and dreaming takes place when we're asleep. So all we can get is after-the-fact reports. If we were going to make any headway on this problem, we had to find a better way to explore the unconscious. In his hunt for that better way, Carhart-Harris picked up psychologist Stanislav Grof's classic book, Realms of the Human Unconscious, Observations from LSD Research. One of Grof's main arguments was that during psychedelic states, our ego defenses are so diminished that we gain nearly direct access to the unconscious. That's when it clicked. With tools like fMRI, Carhart-Harris could exploit this access. He could take pictures of the unconscious in real time. After finishing his master's, he switched careers and joined David Nutt's lab at the University of Bristol, learning the basics of neuroimaging, doing sleep research, and making an initial foray into psychedelics by imaging MDMA. In 2009, he became head of psychedelic research at Imperial College London and became the second person in history to use fMRI to explore the neurological impact of psilocybin 22 and the very first to explore LSD 23. These were important milestones. This is to neuroscience what the Higgs 24 boson was to particle physics. David Nutt told The Guardian, "We didn't know how these profound effects were produced. It was too difficult to do. Scientists were either scared or couldn't be bothered to overcome the enormous hurdles to get it done. More than anything else, what those first ever imaging studies revealed was the middle ground that Sasha Shulgin never had the tools to map. Shulgin gave us a wider assortment of chemicals to assay and subjective reports about what happened when we did. Carhart-Harris closed this gap. He showed us what was going on in the brain, illuminating the neurological mechanisms that lay beneath Shulgin's subjective reports. And these newly discovered mechanisms shed more light on two of the fundamental characteristics of ecstasy: selflessness and richness. Earlier in the book, we explored how the deactivation of key parts of the brain, what's called transient hypofrontality, is largely responsible for selflessness. Carhart-Harris extended this work, helping to determine exactly which parts are involved in that process. A lot of the earlier imaging work on altered states gave us static pictures of the brain, so we made correlations. When we're on LSD, this region deactivates. When we're meditating, that region deactivates. But the technology has improved and we can now take dynamic pictures. This is how we know that the vanishing of self is not really about specific regions deactivating. It's bigger than that. It's more like whole networks disintegrating. One of the most important networks to disintegrate is the default mode network, responsible for mind wandering and daydreaming. This network is active when we're awake but not focused on a task. It's the source of a lot of our mind chatter, and with it, a lot of our unhappiness. But, like many of the brain's systems, the default mode network is fragile. A little trouble in a couple of nodes is all it takes to knock it offline. Early psychologists used terms like ego disintegration to describe the effects of an altered state. Says Carhart-Harris, they were more correct than they knew. The ego is really just a network. And things like psychedelics, flow, and meditation compromise those connections. They literally disintegrate the network. The other important discovery made by Carhart Harris and his team involved the birth of new networks. The scans revealed that psychedelics created highly synchronized connections between far-flung areas of the brain, the kinds of linkages we don't normally make. So when researchers like James Fadiman discovered that psychedelics could enhance creative problem-solving, these far-flung connections were the reason why, or as Carhart Harris explains. What we've done in this research is begin to identify the biological basis of the reported mind expansion associated with psychedelic drugs. Carhart Harris set out to take real-time pictures of the unconscious. And when he did, he saw the unconscious actively hunting for new ideas. It's a discovery that helps to legitimize these substances as performance-enhancing tools for solving wicked problems. And it's one that Carhart Harris feels couldn't come at a better time. A lot of people have been pointing out that the modern world is in crisis. I don't know if I agree with the most pessimistic of those assessments. But I do know it takes significant cognitive flexibility to solve complex problems. So I do think all this research is timely. It's making us a little less afraid of a powerful problem-solving tool going forward. I have a hunch that's going to matter. The Hyperspace Lexicon. On September 22, 1823, a 17-year-old farm boy from Manchester, New York, named Joseph Smith, 25, had a strange dream about an angel named Moroni. The angel told him of a treasure buried on a hilltop behind his house. Upon awakening, Smith climbed that hill and, just shy of the peak, unearthed a gold-leafed book, bound together with 3D-shaped rings and written in strange hieroglyphics he later described as Reformed Egyptian. It contained a prophecy that would alter the course of U.S. history. The book told of a lost tribe of Israelites who had sailed to North America in 600 BC. It recounted the story of a prophet named Mormon and the second coming of Jesus Christ. If true, these ideas would turn nearly 2,000 years of Christian orthodoxy on its head. But there was one small problem. Proof. The angel didn't let Smith bring the golden tablets down Mormon Hill. In fact, by the time Smith translated the Revelation and published it a few years later as the Book of Mormon, the golden plates were nowhere to be found. The angel, Smith reported, had taken them back for good, while many of Smith's contemporaries doubted his story. And subsequent scholars found no evidence of a Reformed Egyptian culture in North America. To the faithful, Smith's account stands as gospel. So compelling was his epiphany that it inspired one of the most successful religions in American history. The Church of Jesus Christ of Latter-day Saints transformed the barren deserts of Utah into a garden theocracy, constructing massive temples and a global mission network that impacts millions to this day. And Joseph Smith was by no means the first person to have a prophetic vision that then birthed a religion. Moses fathered three of the world's largest traditions: Judaism, Islam, and Christianity, when he came down from Mount Sinai with two stone tablets written by the finger of God. But this time as well, the problem was proof. When Moses returned to camp, he found the Israelites worshipping a golden calf and raged at their idolatry. He smashed the newly forged 10 Commandments into shards. It was the first time in recorded Western history that God had directly communicated with humanity. And the evidence was destroyed almost as soon as it had been created. The chastened Hebrews had to take Moses' word for it. Until recently, those sorts of visions were always unverifiable. Access to ecstasis was rare, understanding its mechanisms, and meaning rarer still, when someone did find a hotline to God. The experience was usually a one-off, unrepeatable, and impossible to validate. The only way to gauge the truth revealed in these states was to assess the conviction of the original visionary or listen to the retroactive stories of their followers. But Sasha Shulgin and those researchers who have come after him have changed our relationship to revelation. Because, say what you will about pharmacology being a cheat code to the mystical, there's no question it works. People can reach transcendent 26 states through meditation or similar trance-inducing techniques. New York University neurologist Oliver Sacks once explained, "But drugs offer a shortcut. They promise transcendence on demand. No climbing a mountaintop and waiting for lightning to strike. No sitting on a cushion wondering if nirvana will ever arrive. Pop the pill, take the hit, and pretty soon you're undeniably someplace else." This ease of access means more people can visit these states more often and collect more data. As a result, they no longer have to treat one person's epiphany as written in stone truth. Not long after the publication of PIHKAL and TIHKAL, online message boards and forums began popping up to provide clandestine recipes for kitchen chemists and detailed maps for explorers of inner space, referring to Erowid 27, one of the largest and best regarded of these online repositories. Author Eric Davis writes, "By far the most entertaining vault contains thousands of experience reports logged by psychonauts flying high on exotic cacti. prescription pharmaceuticals, and newfangled phenethylamines. At once formulaic and bizarre, these reports provide details largely lacking in the hazy trip tales of yore. This open-source approach to pharmacology has given us a way to fact-check ecstatic inspiration, moving us from the one-to-many route, a la Moses and Joseph Smith, to a many-to-many model, rather than having to take anyone's word for what happens out there. Explorers can now repeat the original experiments and see for themselves. It's a development that appends the closely guarded and often reactionary world of revealed truth and religious insight. Take, for example, psychiatrist Rick Strassman's 28 research at the University of New Mexico. In the early 1990s, Strassman was searching for a naturally occurring substance in the human body that could prompt mystical states, which he hoped might provide a way to explain the epiphanies of Moses and so many other historical prophets. Initially, he turned his attention to melatonin, but, disappointed with the results, soon decided to focus on its cousin DMT. DMT made sense as a candidate. It occurs naturally in the human body, yet when vaporized or injected, becomes a powerful psychedelic. Strassman was shocked by how powerful it was. I had over 20 years in experience, 29 in training and study in Zen monastery, and I was expecting those kinds of enlightenment experiences from DMT, but Strassman's study group didn't experience anything that could comfortably be described as Buddhist. More than 50% of his research subjects blasted off to distant galaxies, had hair-raising encounters with multidimensional entities, and came back swearing that those experiences felt as real, or in many cases, more real than waking life. When Strassman published his findings in the Buddhist review Tricycle, there was a considerable backlash. He was roundly criticized by readers and disowned by his meditation community for suggesting there might be something else going on in mystical states besides Zen oneness. In 1995, it all became too much. He shut the project down, sent the remaining chemicals back to the D, and retired to the mountains of Taos, New Mexico, to knit alpaca sweaters. But the precedent Strassman set proved compelling. In the wake of his study, unsanctioned use of DMT and its more potent cousin, 5-MeO-DMT, skyrocketed. An experience too strange for all but the most ardent 60s trippers, became the first truly digital age psychedelic. Knowingly referenced in DJ samples, discussed at length in podcasts, and inspiring online forums all its own. One forum in particular, the Hyperspace Lexicon, reflects a collective effort to codify and make sense of the utterly novel landscape of DMT. The lexicon is packed with neologisms, 30 that would have made James Joyce proud, among many others. There's luminergastic, for the orgasmic experience of white light, mangatanglement, referring to the brightly colored fractal building blocks of DMT reality, and ontoseismic, for the utter shattering of your worldview after glimpsing the DMT universe. But tucked beneath the creative nomenclature, the Hyperspace Lexicon reflects a watershed in how we relate to ecstatic revelation. For a concept to make it into the lexicon, it can't have come from anyone's singular experience. Rather, the new idea has to resonate with a critical mass of the community, and even then, it's taken with a grain of salt. Consider the first entry under a, for Akashic book, an imagined but seemingly real book that, as the lexicon says, contains deep knowledge in a language you can't read but do understand. It is so profound. It contains exactly the right wisdom for you at this moment. Whether Moses and Joseph Smith perceived that same Akashic book as stone tablets or golden plates is impossible to prove. However, unlike the lessons of these prophets, no one is being asked to take insights gleaned from that book at face value, while the lexicon specifies that the knowledge it contains is profound, even omniscient. It then qualifies that with "for you at this moment." Another example of the provisional nature of the lexicon is the phrase "end of the line," defined as when having a DMT experience and you feel as if you have reached the absolute point, the alpha and omega of the universe, and your entire existence. Then you are having a the end of the line type breakthrough. It may very well not be true at all, but for you, subjectively, it feels as if. So, even though an end-of-the-line experience might have birthed Hellfire zealots in earlier days, today we have anonymous explorers bracketing the certainty of their experience with phrases like "you feel as if," and "it may very well not be true at all." If you put this all together, what seems to be emerging in the aftermath of Shulgin, Carhart Harris, and Strassman is a kind of agnostic Gnosticism, an experience of the infinite rooted in the certainty that all interpretations are personal, provisional, and partial. As a result, no one can claim their particular vision of the divine as correct if there are thousands of other visions with which to compare it. And anyone who does try to claim the spotlight, even a few decades ago, they could have started a cult. These days, they'll just get trolled online, then ignored. And what that does is leave more room for open experimentation. It disempowers anyone tempted to escalate his position and privilege, and empowers everyone else to make sense of their own experiences. When the physicist Enrico Fermi famously guessed the number of piano tuners in Chicago, or the number of stars in our galaxy, he did so by applying provisional estimates to impossibly large problems, and while never exact, his guesses often landed within an order of magnitude of the actual number, enough, in other words, to act upon. Today we're following Fermi's lead, applying the power of big data to approximate answers to the big questions. One or two data points like a Moses or a Joseph Smith can't ever make a trend, but what about 1,000 data points? 100,000. A picture is starting to emerge of the worlds inside us, and while it's no less strange, it is arguably a good deal more accurate than the singular epiphanies that have come before. The molecules of desire. In 2010, chemist Lee Cronin, 31, saw a demonstration of 3D printing while attending a conference in London. The technology caught his attention. At his own lab, he was always having to fabricate equipment, so he wondered, could 3D printers solve this problem? Cronin returned to the University of Glasgow, where he was a professor, and organized a feasibility workshop. It didn't take long to discover that bathroom sealant, the kind available in any hardware store, could be used as raw material, letting him print test tubes and beakers in any size or shape. He also found that the printer could be used to create simple molecules by filling it with chemical inks, the reagents from which molecules are built. Cronin prototyped a rudimentary chem printer. Since then, Cronin has moved past formulating simple molecules and into more complicated compounds. His short-term goal is to figure out how to print over-the-counter medicines like ibuprofen. His long-term goal is to create a set of universal inks capable of making any drug from scratch. Almost all drugs are made from simple molecules like carbon, hydrogen, and oxygen, Cronin explains, as well as easily available materials like paraffin and vegetable oil. With a 3D printer, it should be possible that with a relatively small number of inks you could actually make any organic molecule. This discovery would make prescription drugs downloadable, allowing anyone anywhere access to the medicines they need. But it will do far more than that. Of course, says Cronin, this printer will also lead to new frameworks for discovery and increase the possibilities of new kinds of mind-altering drugs, while all manner of psychoactive plants are available online, allowing the adventurous to distill potent psychedelics with little more than a crock-pot, some mason jars, and a turkey baster. The D and Interpol can still shut down these gray market suppliers. But Cronin's 3D drug printer renders that kind of oversight almost impossible. After all, how can you regulate access to controlled substances when the raw materials have become as pedestrian as paraffin wax and vegetable oil? What's more, 3D printers have user-friendly interfaces, so all that's required to work one is the ability to point and click a mouse, and they're inexpensive, so using them doesn't require big grants or costly labs. Their combination of simplicity and affordability puts every step of the chemical formulation process within reach of anyone with an internet connection and a power outlet. So, for those interested in taking one of the formulas from Shulgin's cookbooks and modifying it to create the next great alphabetamine, simply hit print. And Cronin's 3D chem printer isn't the only development reshaping pharmacology. By treating the 4 letters of the genetic alphabet like the ones and zeros of computer code, synthetic biology gives us the ability to program living cells with the same ease that we program computers. And once the code looks right, send it to a DNA synthesizer, and within a few days you'll receive a freeze-dried vial in the mail filled with your genetic creation. Not surprisingly, synthetic biologists have already figured out how to use this process to produce psychoactive substances. In August 2014, researchers at Stanford 32 announced they had genetically engineered yeast to produce the painkiller hydrocodone, conventionally farmed. Poppy plants take about a year to grow enough opium to make this drug, but this new yeast can do the work in days. The Canadian company Hyacinth Bio, 33, meanwhile, is engineering a different yeast to produce THC and cannabidiol, 2 of the active ingredients in marijuana. This is really just the beginning. 34 explains Autodesk distinguished researcher and synthetic biologist Andrew Hessel. Pretty much any substance made by a plant, tree or mushroom, including all the neuroactive substances, is within reach of synthetic biology. We're not there yet, but within a decade or so this one technology should be able to tickle all the same receptor sites in the brain that mind-altering substances impact. Author Michael Pollan argued that the botany of desire, the idea that intoxicating plants shape us as much as we shape them, has played an unsung but important role in the evolution of culture. But no matter how influential these plants may have been, historically our ability to use them has been held in check. If the plant didn't grow nearby, If it wasn't on the list of socially sanctioned substances, potential explorers were out of luck. Pharmacology is such a potent force for ecstasy because it changes the nature of this game. With chemical cookbooks, rigorous neuroscience, crowdsourced lexicons, and now democratized means of production, we're freed from the geographic and cultural limitations we inherited. By giving us access to not just the botany of desire, but the molecules of desire, we can continue to shape these compounds even as they inevitably shape us. It's convolution compressed from millennia into minutes.